Hello everyone, welcome back to AI Tutorials. Today we are going to talk about what is gradient descent and what is propagation. What do they mean in context of neural networks? In very simple terms, I will try to explain what are these terms and how they are used in different models. First, let's take a step back and just in the previous video, I had explained about loss function. What is loss function? Basically, when you create a model, right, the model there is some algorithm, the model goes through the input parameters and tries to predict an output. During the training phases and even afterwards, after implementation, the predicted value would not be close to the actual value, right? Because you know the actual value and you know what your model predicted, and the difference between the two is called the loss, or it is also known as the cost function. Okay, loss or the cost function. The whole goal of this training and having different neural networks and different nodes is to minimize the cost, minimize the loss, which in simple terms means have the model predict as close to reality as it can get, or as close to actual values possible. So if, let's say, for example, if it's a handwriting detection model, so if you're writing the digit 2, you would want it to predict 2 and not say 1 or 10 or not 10, sorry, 1 or 9 or 8, something like that, right? You'll have the model predict the value as close to the actual value so that your loss is minimized. Now, gradient descent works on that. Now, basically, now again, taking a step further, next step, what do we need to compute the loss functions? So what do? We need weight and biases. One bias, sorry. We need different weights. So let's take a simple, very simple example, okay, where we have just one node in each level. Okay, the one node in the hidden layer. So this is the hidden layer of the neural network. This is the input parameter, and this is the guessed output parameter. So, and this, the connection between them is the weight. And to the weight, you add the bias, and that makes up your cost function, goes to the input layer and goes out. Okay, so let's say, for example, this was a pixel based on whose input. This is assuming it's a training data. So you know this digit is here is 2. You apply the cost function, comes here, some function is applied here, again weights and biases are assigned, and then it comes here. Okay, so let's say the input here was 2. Okay, and the output that the model predicted was 3. That's not right, right? So there is a loss of 1. So the difference between the predicted value and the actual value. Okay, now see here, what happened in between this? How did it arrive at 3? It used some weight, which means weight given to a feature, added a little bias, and came to a conclusion here. On that conclusion, it again applied some function, which had some weight, and a bias was added, and then the output was predicted. It was 3, but it's incorrect. We expect the model to give us the correct answer, which is 2. So what we will do is, so we know this is 3 is wrong. Then what do? We come back here, we adjust this weight. Okay, so so let's say the weight was 5. Okay, for example, okay, the weight was 5 here, bias was 2. Then what we do is we say reduce the weight. Okay, so from 5, let's say we go to 3 and see the output. Okay, so let's say, for example, actual example of weight and bias. So let's say 5 and the weight was 3. Okay, sorry, the weight was 3 and we got the output 3, which is incorrect. We want to correct it. What we do? We go back here. Okay, we change this. So let's say we change this weight and see, try to go 4. Okay, try to make it 4 and see the output. Run this algorithm again. And now what it did? Oh, okay, it predicted 4. Okay, it went here and predicted, okay, let's say 5. Okay, just that this 4 and this 4 doesn't get confused. So what happened was this does not work. So this change from 5 to 4 does not work because we went, our loss increased instead of decreasing. Okay, so what we go? We go back here. Okay, so 4 is not right. We go here and we come back. So this is not right. So may make it 6. Okay, so in 6, does it work? So it went to, so let's say 1. Mm-mm, still doesn't work. Okay, still wrong output. What do we do? Go back here, change it. So let's say 7. Okay, see, all the time what we are doing is going back. Okay, now this is just one level. Okay, we have to go one more level back, adjust this also. Okay, so this is 7. So let's say for example this was 7. Take another this thing, and here let's say it was 2, 2, and the bias was 1. Okay, so we adjusted this, and then we also adjust this. So see, we are going back. So this is our input, this is our output. So what we are doing in order to get the correct output, what we do, first go back one level, adjust the weight and this thing, then go here, adjust it, weight and bias, and then come to the final, run the model again on the training data and see, oh, now it's predicted. So let's say now the predicted value is 2. So this works, right? Because now our loss is 0. So see the steps that we took. We randomly chose some weight and bias at each level. We ran, or we passed the input through our algorithm, through a cost function, and the model predicted some value. We adjusted our weights based on the output, whether we want to increase the weight or decrease the weight. As our output came closer and closer to the prediction, okay, we were going through gradient descent, which means what parameter do we change the most so that our output is as close to the actual value, so that the model can guess actual value closest possible. Now, see, in digit, it's always possible to predict a exact number, right? But if it's a painting or a flower or some image recognition, it will be closer to something, right? Like, say, for example, tulips and rosebuds, they look very, very similar. So, adjusting the weights would be difficult. So, this is back propagation. So, back propagation in simple language, what it does is when your output is not what you expected, okay, because this is training data, you know what should the output be or what is the correct output. This is all during training. Then what you do is you go and adjust the weights and biases of the connections between the nodes. So this is back propagation. And the process, this process of adjusting the weights and biases so that our cost or our loss is reduced or minimum is called gradient descent. Okay, so this is a very, very, very simple example just for you to understand one node in each layer, right? Let's say 2 layers. Let's take example of 2 input parameters, 2 nodes in the hidden layer, and this is the two output parameters, what it could predict. And each node is connected to every other node. Okay, what we do? Again, same thing. Each connection will have its own weight and biases. Okay, so each connection here will have some random, not the same. Okay, some random. So let's say this is 5 plus 4. This is this connection. Okay, then for the other one, For this one, it could be 6 plus 7, whatever, right? So weight, each connection has its own weight and own bias, which passes through the algorithm, okay, here. And then this also exactly same will have some weight and biases. And what we are going to do, so let's say this is 3 plus 4, okay? This is just 3, just giving an example. So what we do is, during training phase, when we are training the model, we input the features. What happens is, the features are connected to passed as a pixel here to every other node, and each pixel is connected to every other node. Each node has our function, okay, or has the algorithm which the model should run it, the input parameters against, and it predicts the output. Depending upon whether the output is correct or incorrect, we go back, adjust the parameters. We go adjust the weights and parameters and go on repeating this process until our outputs are what we expect. Okay, so gradient descent is actually the process of changing these weights and biases so that our loss is minimum. Okay. And back propagation, why back? Because you start from here, adjust this weight, then go back here, adjust this weight, and then see. Or probably adjust this weight, not necessarily this. You can go and adjust this weight and then compare the output with the actual input value. And this happens in hundreds of nodes with that are connected in neural network. Okay, but all this is done internally, like you don't do it actually manually. You go and adjust each weight, which will be crazy. Like, imagine this is just 4 nodes and two nodes in the hidden layer. And in reality, there are hundreds of nodes, right? Because they're trying to mimic the human brain. Okay, each node is for a specific function, okay, has a specific function which it goes through and contributes in predicting the value. Okay, so this is, in very, very, very simple terms, what is gradient descent and backpropagation. Hope the example makes it clear to you. Okay, so we start with very simple model, we go back, adjust the weights and biases until we are satisfied or the model predicts the correct value. So this is all it is to gradient descent and backpropagation. Hope you understood the concept, and if you like it, do like and subscribe the video, and stay tuned for more concepts to come. Thank you.